MS Ramaiah University of Applied Sciences.
Hi students, let us discuss design and verification of binary to gray code converter. Aim of the experiment is to design, construct and verify a binary to gray code converter. Gray codes are used in position encoders, linear encoders and rotary encoders in preference to straightforward binary encoding. This avoids the possibility that when several bits change in the binary representation of an angle, a misread will result from some of the bits changing before others. Due to the Hamming distance properties of gray codes, they are sometimes used in genetic algorithms in modern digital communications. Gray codes play an important role in error correction. Digital logic designers use gray codes extensively for passing multi-bit count information between synchronous logic that operates at different clock frequencies. The truth table for binary to gray code converters is shown here. The K-maps for binary to gray code conversion is as shown here. The logic diagram for binary to gray code conversion is as shown here. The apparatus required for this experiment are trainer kit, connecting probes IC 7486. Procedure for verification of binary to gray code converter functionality. Collect the components necessary to accomplish this experiment. Plug the IC chip into the breadboard. Connect the supply voltage and ground lines to the chips. Pin 7 is ground and pin 14 is plus 5 volt. Make connections as shown in the respective circuit diagram. Connect the inputs of the gate to the input switches of the LED. Connect the output of the gate to the output LEDs. Once all connections have been done, turn on the power switch of the breadboard. Operate the switches and fill in the truth table. Write 1 if LED is on and 0 if L1 is off. Apply the various combinations of input according to the truth table and observe the condition of output LEDs. Conclusion. The binary to gray code converter is designed and verified for its functionality.
Hi students, name of the experiment is to design and verification of binary to gray code converter. Aim of the experiment is to design, construct and verify binary to gray code converters. The operators required for this experiment are digital IC trainer kit on which we are going to perform the experiment. So here you can see on the top of the digital IC trainer kit, you can see the knobs here. So 10 are in the red color, 10 are in the black color. So these are the output knobs. So here the bottom you can see the 10 black color knobs. Here we are going to connect the inputs, and inputs can be varied by varying the toggle switches which are present here. So if you keep the toggle switch to the top position, that means the input is high, and if you keep it to the low position, that means the input is low. So output can be verified by looking into the LEDs. If the LEDs are on, that means that particular output is high. If LED is off, that means the particular output is off. And here also you can see there are 4 IC bases, so where you can place the ICs. Each IC base has a IC slot, so where you can place a IC. So here each IC base consists of 16 slots. So and also there are 16 pins at the left side of the IC base as well as the right side of the IC base. Total 16 pins are there. So these are internally connected to the each slot, and also each IC base consists of VCC and ground. So VCC and ground are used to give the power supply to the IC connected here, and at the bottom you can see there is a clock signals of various frequency 1 Hz, 10 Hz, 100 Hz, 1 kHz and 10 kHz. And at the right side you can see there are two yellow color knobs which are used to check the conductivity of the patch cords. So if you can connect the patch cord here and you can see if the LED bulb is on and if the beep noise is coming, that means the patch cord is working properly, otherwise the patch cord has some problem. 7486 IC. So this is the IC we are using in this experiment. This is XOR gate 7486 and patch cords. These are the patch cords we are using to connect the logic diagram. So before using any patch cord to connect the given logic diagram, we have to check the continuity test for each patch cord. Take the patch cord, turn on the power supply to the digital IC trainer kit. It is turned on now. Now place the patch cord between the continuity tester knobs and you can see there is a LED on and there is a beep noise. So this means the patch cord is working fine, and similarly we have to check continuity test for all the patch cords which we are using for the experiment. Now let us place this IC into the IC base. Before placing the IC into IC base, we have to make sure that there is a notch in every IC. The notch should be always in the upward direction before placing into IC base. So I am taking it and I am placing it into the IC base first. After placing it, close the lever and make sure the IC is not coming out. Now let us start connecting the circuit as per the logic diagram. So before connecting the circuit, I will connect VCC and ground for the IC base. It will give the power supply to the IC connected. Pin number 7 represents ground, pin number 16 represents, or pin number 14 we can say, since we are not using the last two slots of the IC base. Pin number 8 and pin number 9 are not in use. After pin number 7 we have to consider this as a pin number 8 and so on. It will go up to pin number 14. Now as per the logic diagram, there are 4 inputs and 4 outputs. Inputs are B3, B2, B1 and B0. Outputs are G3, G2, G1 and G0. So now pin number 1 of the XOR gate is connected as one of the input, that is B3. I am connecting to the input knob. And pin number 2 of the XOR gate is connected as one more input, that is B2. Pin number 3 of the XOR gate is connected as the output, that is G2. Pin number 4 of the XOR gate is connected to pin number 2 or input B2. I am connecting here input B2. Pin number 5 of XOR gate is connected as input B1, and from the same input B1 we are connecting to pin number 9 of the XOR gate. Pin number 10 of the XOR gate is connected as one more input, that is B0. Pin number 6 of XOR gate is connected as third output, that is G1. Here I am connecting. Pin number 8 of the XOR gate is connected as the last output, that is G0. And one more output, that is G3. I am connecting here. G3 is directly connected to pin number 1. So this completes the circuit connections. Now we will verify the truth table according to the given truth table. So before that we have to turn on the power supply to the digital IC trainer kit. So you can see the LED bulb is on, so that the power is on for the kit. Now for the input combination, so there are 16 different combinations we can go. So for the first combination, the input is 0 0 0 0, then output also is 0 0 0 0. Now for the next combination 0 0 0 1, you can see output is 0 0 0 1. For the next combination 0 0 1 0, the output is 0 0 1 1. For the next combination input 0 0 1 1, the output will be 0 0 1 0. So for the next combination of the input, that is 0 1 0 0, the output will be 0 1 1 0. For the next combination of the input, that is 0 1 0 1, the output will be 0 1 1 1. For the next combination of the input, that is 0 1 1 0, the output will be 0 1 0 1. So for the next combination of the input, that is 0 1 1 1, you can see the output is 0 1 0 0. So next combination of the input is 1 0 0 0, the output combination is 1 1 0 0. For the next input combination, that is 1 0 0 1, you can see the output here, that is 1 1 0 1. Now for the next combination of the input, that is 1 0 1 0, you can see all the outputs are high, that is G3 G2 G1 and G0, all the 4 outputs are high. For the next combination of the input, that is 1 0 1 1, the output, first 3 outputs are high and the last output is low. Next combination is 1 1 0 0, you can see the outputs are 1 0 1 0. So next combination will be 1 1 0 1, the output will be 1 0 1 1, and the next combination of the input is, that is high high, that means 1 1 1 0, the output will be 1 0 0 1, and the last combination of the output is 1 1 1 1, that means all the inputs are high. At that time the output, you can see 1 0 0 0. So now it is true according to the truth table, so that means we have verified binary to gray converter. So this completes the experiment.
At MSR UAS, we spark your imagination unlike any other.